Hello, and this time I'm talking about the sum of an arithmetic sequence. Now I'm going to start off by saying what the formula is. I'm then going to go through how it came about and how it works. Feel free to skip over that if you just want to see some examples of me actually doing the questions, then skip merrily. I won't be offended. Well, I won't know, to be fair, but even if I did know, I wouldn't be offended. So what is the sum of an arithmetic sequence? Well, it is Sn, that's sort of the sum, so having added up all the numbers in a sequence, is the number of items in that sequence over 2 times 2 lots of the first term plus the number of terms you're adding up minus 1 times d, which is the common difference or the term-to-term rule. So as I say, if you want to see just the examples, skip ahead. I don't know how far because I haven't rambled on about it yet, but just keep skipping until you get to the examples. They're on another page, and if you want to see how and where this comes from, then stick around. Now another version of this is actually that Sn equals n over 2 a plus, that's not supposed to look like that, a plus l, where that's the last term. But anyway, let me go through an example and show you what it's all about. Now for this I need to tell you about a chap called Gauss. And he was a famous mathematician, and he did lots of things like Gaussian curves and Gaussian space and curvature of space and things like that. And there's a number file video with the crazy guy who gets very excited about how pizza bends and droops, but if you put a twist in it, if you crimp it with your hand on the crust, it keeps the end pointy so you can eat it, and that's all about Gaussian curvature and all that kind of stuff. Yeah, did lots of stuff is my point. But when the story goes, anyway, this might not be true, but the story goes that when he was in school, he had finished his work within 5 minutes. It was like ridiculously fast, and his teacher was like, "Oh, crumbs, what can I give you to keep you occupied whilst I wait, help everyone else?" So he said, "Okay, could you please add up all the numbers up to 1,000, please?" Expecting that, he'll obviously do this quite diligently, and it'll take him a long time. I'll do 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, 15, 21, and it's going to get harder as he goes up. It'll keep him busy for the rest of the lesson, keep him out of my hair. Well, the problem is that Gauss spent only about 5 minutes on this and got the answer right. Now, I actually can't remember. Oh, I missed a 0 off there. Can't remember, but I think the answer is 500,000 and 500. I might have remembered that wrong, but we'll work out the answer in a bit. He got the answer really, really quick, and then the teacher, as is classic in these stories, spent a good 20 minutes trying to check his work. And it's because Gauss had spotted something quite special. What Gauss had realised is that you don't have to add this up. You can do it by timesing, because you can pair the numbers. If you say the first term and the last term, well, they come together nicely to make 1,001. All right, well, that's exciting. Well, it is exciting when you look at the second term and the second to last term, because this is one bigger, but that's one smaller. So they also add up to 1,001, and so do the next two, and so do the next two. And so actually, rather than saying, well, this is a case of adding up lots of different numbers, you can say this is adding up 1,001 half as many times as there are numbers. Yes, because each pair is 1,001. So he sort of said, okay, well, let's write that out. Let's write this sensibly and write this out. Okay, so I've got 1,000 numbers, but I only want the pairs of numbers, so it's 1,000 over 2. The first term was 1, the last term was 1,000, and I've got 500 of those, so 500 times 1,001. Now he didn't use a calculator, and I don't need to either for this, but I'm going to just show it. So he's adding up 500 of 1,001, and indeed you get 500,000 and 500. So it's really quick and easy to do adding up all those numbers when it forms a sequence. Now that's all right because it's just 1 plus 2 plus 3 plus 4, but surely there'll be a good way, it'll still work, I mean, it's a good method, even if the numbers form a pattern. So 2, 5, 8, 11, 14. Hopefully you can see that these numbers are going up by 3 each time. So if I wanted to add these numbers up, now obviously I wouldn't bother if it was just these 5, but we can still do it. because although these go up by 3 this time, not by 1, if you add the first and the last together and you get, what's that, 16, when you add the next two together, this is 3 bigger, but this is 3 smaller. So it cancels out, and actually you still get 16. And all right, there's an odd number, but that doesn't matter because it just so happens that the middle number will always be half the sum that you're looking for anyway. So that number on its own is half, so that it will still work. So let's do the same method. Okay, so the sum of 5 values, but we'll just put S, not S5. The sum for these 5 values is the number of values, 5 over 2. That tells you there's 2.5 pairs. And the numbers are the first number plus the last number, which we said was 16. And then we just work that out. So that's 8 and 8, so it's 40. Now you could actually work this out. So 10, 20, 30, and then 1, 4, and 5 make 40. So we've got it right. So it does seem to work. But what if we didn't know? What if instead I said, oh, no, this is just, I haven't written it all out, you know, here's the sequence, but I want the first 80 terms. So, you know, these are the first 5, but I want all 80 worked out. So I want S of 80. Right, okay. Well, that's going to be N over 2. So the number of items over 2 is 80 over 2. Well, that's fine. And then the first term, well, I know that, that's 2. Now I'm going to use A as the first term. And then I would normally add the last term. Well, what is the last term? Well, we can actually work out the nth term rule for that. And so the nth term rule, if you think about it, to go from the first term to the nth term, we need to add on the common difference D, okay, or in this case 3. We need to add that on, not n times, because we're going from 1 to n. So the difference between these is n minus 1. So I need n minus 1 threes adding up, and that's my common difference. So I need n minus 1 threes adding on to the first term to get the last term. So I need to add that on to the first term. So that is the first term, and the last term is the first term plus n minus 1 of these differences. Okay, and we can simplify that to what we had at the beginning, which is a plus a is 2a. And then we get our formula. So in this case, it's 2 lots of the first term, 2 times 2, plus there's 80 terms, so 80 minus 1 is 79 times the common difference of 3, and we just put that onto our calculator. So 80, well, I don't need to do that, 40 is 80 over 2, times, bracket, 2 times 2, I can do that in my head, 4 plus 79 times 3. I'll let the calculator do that one. And so the total of this will be, the first 80 terms, all added up, will be 9640. Now, if you don't believe me, you can go through and add them all up separately if you want, but, you know, hopefully you can see that this is something that is going to work. Now, it doesn't matter if you like the first plus the last, you can memorize that, but in a GCSE, that is given to you as n there, as that formula, but if you want the first plus the last one from what Gauss did, then that's absolutely fine, you can do that, no problem. So let's have a look at my 2 examples. Given this, well, we've kind of just done this example, haven't we? So 15, 18, so this is plus 3, that's the common difference, so D equals 3, A equals 15, N equals 50, yes, and find the sum. So the sum is N, 50 over 2, times the bracket, 2 times A, which is 15, plus N minus 1, which is 49, times D, which is 3, and I'm just going to reach for the calculator, 25 times 30 plus, bracket, 30 plus 49 times 3, and our survey says 4425 is the sum. It's straightforward and easy as that. Right, slightly more complicated here because they've told us the 19th term of an arithmetic sequence is this. The common difference is 7. Find the sum of the first 200 terms. So I need to find the first term. Okay, well that's not too bad. To go from the 19th term down to the first term is 18 steps back, isn't it? 19 minus 1 is 18. So 18 steps back of 7. Okay, and if we do our 19th term, 132 minus that, that will give us our first term. So what was that? 132 minus 18 lots of 7 is 6. So now we have A, we have D, and we have N. So again, it's just a really easy calculation. So the sum is 200 over 2 times the first term, 2 times the first term, plus N minus 1 times the common difference of 7. And again, it's just a case of putting that into the calculator. So 100 times bracket 12 plus 199 lots of 7, and that equals 140,500. 140,500. Nice and easy. Can you be asked to do it backwards? Yes, of course you can. If they told you that sum and asked you for something over here, then you just have to rearrange it. You'd have to work this out and then divide by that number, and then depending on what you wanted, add or take away things and then divide, and just normal solving. If you've got this calculator, you could use shift solve to check your answer. By typing it all in and shift solve and all that kind of stuff. Okay? So hopefully that gives you a little flavour of how to do these sum of arithmetic sequence questions. And remember that Sn equals n over 2 bracket 2a plus n minus 1d is given in... that's a plus. Is given in the formula book for GCSE. Maybe A-level as well, can't remember. Definitely GCSE, that's given. But you might like to use the Sn equals n over 2, the first plus the last, if you feel that's more appropriate, just to work out the last value and work it out. That's fine, but you have to remember that one. But that one kind of makes sense from what Gauss did. So if you remember the story, I remember that one, and then that helps me to remember this one afterwards. Okay, that's enough from me today. Comments down below if you have any. Otherwise, ta-ra for now.